Good morning, class. You're welcome to today's lesson. Today we want to talk about the production theory. So this will be our outline. We'll look at the meaning of production, then we'll look at the production function, and we'll talk about isoquants, and then we will talk about the production process. First of all, the meaning of production. Production involves the various inputs that are transformed into some form of output. So when inputs are transformed into output, we call it production. And production is an important economic activity which satisfies the wants and needs of people. So the output produced are supposed to satisfy the wants and needs of people. Now the inputs we mentioned, they are also called factors of production. So inputs of production or factors of production. And inputs of production and factors of production, we have land, labor, capital, and entrepreneurship. For entrepreneurship, it embodies the managerial functions of risk taking, organizing, planning, controlling, and also directing the resources or the other inputs of production. So the entrepreneurship is some form of skills or functions performed by an entrepreneur, a human being, right? So the next thing we want to look at is the production function. A production function expresses the technological or engineering relationship between the output of a product and its inputs. So it shows a relationship between output and inputs, right? So it is the relationship between the amount of various inputs used in the production process and the level of output. That is also a production function. The relationship between the amount of various inputs used in the production process and the level of output. So a typical production function can be expressed as this. Q is this F means is a function of F1, F2 up to Fn. So the F's, the F1, F2 up to Fn are amounts of various inputs such as land, labor, capital, etc. And the Q is the level of output for the firm. So if labor and capital are the only two factors of production, the production function can be expressed as K, which is output, is a function of capital represented with K and labor represented with L. So we have a type of production function called the Cobb-Douglas production function. And this is a function that defines the maximum amount of output that can be produced with a given level of inputs. Right. So let us assume that all input factors of production can be grouped into two categories such as labor and capital. The general equilibrium for the Cobb-Douglas for the production function is Q is equal to, or Q is a function of Q is a function of capital and labor. K represents capital and L represents labor. But for the Cobb-Douglas production function, this is how it's represented. It is in a quadratic form. So Q is equal to A, which is a constant, K to power alpha, and L to power beta. That is a typical Cobb-Douglas production function. When we put figures in, you realize that this is a number, and this is also a number, but it's normally expressed in a fraction less than 1, and this is also a fraction less than 1. Right. So in this case, the Q is the maximum rate of output for a given rate of capital and labor, and the constant is also greater than 0, but is always less than 1. And one takeaway is that we can have the alpha and beta. As I mentioned, they are expressed in fractional decimal. Normally when you add the alpha and beta, you are supposed to get 1. So if alpha is 0.4 and beta is 0.6, you realize that alpha plus beta will give you 1. The next thing we want to look at is isoquants. We'll look at the meaning of an isoquant. Isoquants are a geometric representation of the production function. So it's a geometric representation of the production function. It is also known as iso product curve. So let's look at iso. Iso means the same and quant means quantity. So isoquant is different combination of inputs to produce the same quantity of output. That is an isoquant. So the same level of output can be produced by various combination of factor inputs. So far as the same level of output is produced, no matter the number of inputs, the number of labor, the number of capital used, different combination of these inputs, if they produce the same level of output, the result is an isoquant. So isoquant curves, an isoquant curve is a line joining different combination of input to produce a given level of output. We'll look at the shape of the curve and you see. But one thing we want to also mention before we move on is the marginal rate of technical substitution. A normal circumstance, if you have to produce the same level of output but with less labor, that means you would have to increase capital. So in that case, you are substituting capital for labor. Sometimes you want to increase your labor, you have to decrease your capital to produce the same level of output. So the rate at which the two factors of production are substituted for each other is what is called the marginal rate of technical substitution. Now this is an example of an isoquant. As you can see, we have labor and we have capital. You can decide to combine different quantities of these factors of production. So K1, looking at K1 and K2, K1 is more than K2. So you can employ more capital, and when you employ more capital, you are likely to employ less labor if you want to produce the same level of output. So this is the isoquant. Okay, what about if you employ less capital, say K2? So K2, you reduce your capital, then that means you need to increase your labor in that regard. So this is an example of an isoquant. Okay, let's look at the characteristics of an isoquant. The first is isoquants are everywhere dense in an isoquant map. So we'll look at an example of an isoquant map and you'll see. So isoquants are everywhere because if you can provide you can produce different levels of outputs so far as you have some inputs. So they are everywhere dense. And the second is isoquants of higher levels have higher output levels than those lying at lower levels. So this isoquant, for instance, if I should draw another isoquant here and it is higher than this, it means that it represents a higher level of output than what we have here. So that is also another very important characteristic of an isoquant. The third is isoquants do not intersect. We'll look at a typical example. Isoquants do not intersect. Why? If isoquants intersect, just look at this. If this isoquant intersect this, at this point, this is higher than this, so we should consider this isoquant as a higher level of output than this. But it intersects and it becomes lower. So at this point, we should consider this lower than this. But an isoquant is a curve, a representation of the same level of output. So if this is 7 output, at this point it should be 7 output. And if this is 10 output, at this point it should be 10 output. But you see that at this point it is lower than this, which cannot be. So isoquants do not intersect. And the fourth is isoquants are concave upward or convex to the origin due to the law of diminishing marginal rate of technical substitution. Okay, so as I mentioned, the marginal rate of technical substitution is the rate at which two factors are substituted for each other. One fact is that as these factors are substituted for each other, if you need to reduce capital and increase labor, look at the margin. You reducing capital, you reduce it by a very large margin, in order to increase labor by a very small margin. This is called diminishing rate of marginal technical substitution. If you want to employ more people, let's take this one for instance. You have, assuming you are employing L2 and K2, and you want to employ more people, you have to reduce your capital. That's true, but your reduction in capital will result in you increasing your labor even more than reducing your capital. That is called diminishing marginal rate of technical substitution. The rate keeps diminishing, right? So isoquants are concave. That makes for the curve. That is why it is not a straight line, but it looks convex to the origin. This is the origin, so it pointing here is convex, but if it is pointing outside, it is concave. So it's concave upwards or convex to the origin due to the law of diminishing marginal rate of technical substitution. We'll pause here and continue in the next slide. Thank you.